Here we go, section 1 for day 2. This is going to be a ton of information, so let's just get started. Don't be overwhelmed by it. As we just talk about things, remember, focus on one thing at a time. We got letter A, what does that mean? We got letter B, what does that do to a graph? Letter C and letter D. Think of them as one step at a time things. And then there's an exception that I'm going to try to explain at the end of this, but let's just start. So, anytime you have a question over like, whoa, did that really make sense? I think he's kind of missing it here and there. Go to Desmos.com and you can type in these equations and just play around with them and see how it shifts and moves and stuff. But you are going to be expected to be able to do this stuff without Desmos, like literally by hand, as I'm going to demonstrate. Use Desmos to help educate, but ultimately, if you have to take a test in class, you're going to have to be able to write it down and actually do it yourself. So with that in mind, we're going to start with a parabola, okay? Because this is going to teach us something about the letter C. The letter C over here, notice in red, if this is a plus, it's going to move the whole graph to the left. If it's a minus, it's going to move it to the right. Now there's this big grandiose way that I explain it so that it's logical, but we're not going to take the time to do that. Go to Desmos if it doesn't make sense or if you don't believe me. But here we go. Y equals x squared, parabola. The vertex is right here. What does this minus 1 do? Well, according to the rules, it moves the vertex to the right 1, and then I would just redraw it like that. So with that being said, what does x plus 1 do to that vertex? It's going to move it left 1, so it would put it right there instead of the origin, and then you'd have the parabola. Now I'm going to erase this because this is the space I'm going to use. Hopefully we'll have time for the grand finale. So I'm going to go through all of this and finish over here, and hopefully we'll do it under 15 minutes. So here we go. Stay with me. All right, y equals sine of x. Some hidden clues. There's my A. That's where A is. What does that tell me? It tells me the amplitude. Also, if it's negative, it'll flip it over the x-axis. Keep that in mind. Here's a little invisible B. What does that tell me about this graph? Well, if B equals 1, and I put it in this formula, the absolute value of B is 1. The absolute value of 1 is 1. Which my period is telling me, hey, my period is going to be 2 pi and my amplitude is going to be 1. We already know that because we've done this in 1 for day 1 a few times, but we're going to just start with the basics, redraw this. We're going to go up and down. I'm just going to do 1 period just to save some time. Notice the amplitude is 1 here or 1 here. Notice the period goes from negative pi to pi. Yes, it keeps going. But I'm just going to focus on this 1 period. So there it is. There's the sine curve. How did I know it just goes through the origin? Remember, it just does. Go on to this one. What does this 2 do to this amplitude? Well, it doubles it. So I'm going to use dotted for this one. Just so every valley that's down 1 is going to be down 2 now. This peak is going to double in height. And that's what that did. It changed the amplitude. It doubled it. Now we're going to throw some more at you. Now this and this are the same. So if we look at the dotted line, nothing changes. Well, what does this do? A lot. If B equals 2, and I use my formula for period, 2 pi over the absolute value of 2, it's just going to be 2 over 2, which is just 1 pi. You got to think simple. The original period is 2 pi. From negative pi to pi. So these walls have to close in. And I'm going to go ahead and pick a different color just for the grand finale. So how do I have the same graph in half the time? Well, this wall or boundary needs to move into here. This boundary needs to move into here. So that point would move here. This point would move here. Now notice it went up to 2 and down. We just have to do it in half the time. Same thing here. It went down to negative 2 and up. We just have to do it in half the time. So you can see the dotted one got squeezed. You see? So the period got shut down to pi. How do I know? Negative pi over 2 to pi over 2 is pi. That's what that adds up to. So we shrunk it, okay? Now, technically that's called a horizontal shrink by 2. or a half. Remember when we say shrink, you got options, okay? Because some people think divide by 2, some people think multiply by a half. They're both true. Now what happened to the amplitude? Well, the amplitude doubled, so we would say it was vertically stretched by a factor of 2. So there's the language. Okay, well what about, okay, I guess we're done with that. I didn't need this. Let's move on to this and just add one little twist here. So I see the sine curve. So what I'm going to do is I'm just going to draw it right here. Again, stick with the one period there. It's not perfect, but I'm freehanding it, so it's decent. And I'm going to, one step at a time, I know the amplitude's 2, so that's going to, the peak is going to go up to 2, the valley is going to go down to -2, and now I am to here. Okay, I'm going to erase the previous one just so we can kind of concentrate. And now, what is this all about? Well, that takes us back to the parabolas. Unfortunately, I erased, but what does the minus mean? Well, your instinct might say left, but it's actually right. How far? Pi over 2. What does that mean? 1 unit. It's almost like an x-axis with a 1 and a 2. This is just saying move it to the right, one of these chunks, or pi over 2. So every spot needs to move over pi over 2. So this is going to move to here. This will move here. So you can see it kind of going like this. This spot where it crosses the origin is going to move here. This spot right here is going to move here, pi over 2. And then this spot over here is going to move to here, and there it is. And for you art people, you know, or visual learners, I should say, all we did is move the dotted line, the whole thing, bumped it over pi over 2. So there it was, and now because of that minus pi over 2, it just got shifted over. And that's called a phase shift, but all we're going to say is right pi over 2. Okay, a little abbreviation. Uh-oh, what do we got here? Well, this is the same as this. This right here is actually plus pi over 2. So I should have had this ready to go. But here's pi over 2, and here's pi. Here's negative pi over 2, and here's negative pi. And here's 1, and here's 2, and -1, and -2. Sorry about that, you guys. So it's going to go up and down and up. So there's your sine curve, one period of it. Now let's go ahead and make some changes. So again, it's going to go down to -2. It's going to go up to 2. And there we have our last drawing. So we've made one adjustment. So we'll get rid of the original sine curve. What does this mean? Well, now plus means left. So now I got to bump this thing to the left. So what I'm going to do, and I'm going to do this in purple, I'm going to try it in one move. I just want this whole thing to shift left pi over 2. So this goes to here. So I know this is my starting point. Now I'm going to go like this. And then I'm going to go down like this. And I know it's going to move over like this. And then it comes up right here. So the purple one is my new curve. Okay? And then I got one more thing to do. And that is just bump the thing up too. Right here it says vertical translation. Just up or down. It's super easy. So that's just a simple up or down. And because that's +2, it's not one of these like opposite rules where that's right and that's left. +2 means go up 2. So this is down 2. This is going to come up here. This is right at 0, so this has to come up 2 units. And now I can kind of see what's going on. This is up 2, so it's got to go up 2 more. And this guy has to come up 2. So this comes up 2. And really what I'm doing is I'm just redrawing the thing, and so it's up 2. So it's going to be like parallel to itself, but then it ends like that. I just bumped every spot up 2, essentially, and then just did my best to redraw it, okay? So there is one thing left. Let's see how much time I have. Oh, good, okay. So notice every other example, B is 1, B is 1. B was 2 here. That changed the period. Remember that? But there's an invisible one here, there's an invisible one here. So out of all of these we've done, there's only one of them that actually had the period change. It was that one. And see, all these periods are still 2 pi. You see that from here to here, from here to here. The original black one right there, you know, it's 2 pi. So that period's not changing. So for the grand finale, this is the mother lode. So if you understand this even a little bit, you are really well on your way. So it's 0, negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. And there's 1, there's 2. We'll make adjustments when we need to. Okay, to get these started, you got to think about your foundational graph, and that's sine. And we know, because we've done a few, there it is. What does this do? Well, doubles the amplitude. So see, I'm just making these little shifts, and then I'm going to erase this last one just so my brain doesn't get overwhelmed by what's going on. And if you want to, you can go ahead and say, you know what? I'm going to go ahead and take a look at that, and I'm going to bump this whole thing up too. You see, the order in which you do things doesn't matter either. So I'm going to move that up. This moves up too. And now I can kind of see what this is going to look like. This comes up here, so I see it goes like this. And this guy comes up here, so I know that's my target. This guy goes up here, and so there it is. Okay, perfect? No. Is it getting in the ballpark? Yes. And so now I've done this, and I've done this. Now some of you are saying, wait a minute, so I'm going to move this to the right one. Couple things happen, okay? So one bite at a time. Let's concentrate on this. Remember, this is letter A, letter B, letter C, letter D. If B is something other than 1, then we have a change to the period. The formula is 2 pi over the absolute value of that number, which is just 2. So now it's pi. So now I have another problem. These walls need to come in. The original period was 2 pi. Now I need to bring these walls into right here and duplicate the drawing. So let's go with a different color. So this needs to move in. So here's a wall. Here's a wall. They got to come in pi over 2. So my new wall is going to be here. So look at it. That went up and down in this chunk of time. I need to do the same thing in half the time. And then I need to repeat that over here. So now this outer edge at negative pi needs to be here. So notice it goes down to the x-axis and then up. In this amount of time, it just needs to do it in half the time. And so now I'm to there. And now I need to manipulate this. I've done everything I can, but now we have a different situation. And this is where the phase shift is going to be negative C over B in your packet. Did I lose you? Don't worry about that, because I'm going to look at it differently. I know a couple of things. Number one, I know this is to the right, and then I'm going to not worry about this formula in your packet, but I am going to use this formula C over B. See, I'm not going to worry about that negative, because I've taught it like that before, and it just messes with people. We've already established that minus means to the right. And this C over B formula is what we're going to stick with. So that's a 1 over, oh, I screwed up. I'm so sorry. I'm going to make that just pi. Because our x-axis isn't 1, 2, 3. Our x-axis is now in terms of radians. So I need to change that. Sorry about that, you guys. Screwed up right on video. Busted. So anyways, I need to move it right. C, which is pi, over B, which is 2. What is that? That's 90 degrees. What does that mean? Just one chunk. So this whole thing needs to move over one chunk. So watch this. I'm just going to go like this. And then to here. See, I just duplicated this little U by moving it over 90 degrees. Now I need to move this top half of the curve over 90 degrees. So it needs to go up like this and then down. And that dotted one is my final graph. Again, type that into decimals, and you're going to end up with, a graph that looks like this, but we're only doing one period. All right, we have